Alright, so what we're going to do now is we're going to have a look at redox reactions, okay? Redox reactions. Now the term redox comes from, it's kind of a hybrid of the word oxidation, right? And the word reduction, okay? So redox, as you can tell. Okay, now oxidation and reduction are kind of two opposite processes, okay? They're kind of equivalent, but they kind of go hand in hand, except they're opposites basically. Okay, so oxidation can be defined in three different ways. Okay, oxidation can be defined as a gain of oxygen. Okay, as the name suggests, if something's oxidized, it gains oxygen. Okay, it can be defined as a loss of hydrogen. Or it can be defined as a loss of electrons. Okay, so there are three sort of ways we can interpret it, or three ways that something can undergo oxidation. Okay, these three criteria here. Okay, so loss of electrons. Okay, but the key thing across all three situations, okay, is that they all lead to an increase in an oxidation number. Okay, so we've been through what an oxidation number is, how to work it out. Okay, but all three of these situations will result in an increase in the oxidation number, or we'll abbreviate that to ox number. Okay, so an increase in oxidation number. Okay, inversely, as you can imagine, if they're equal and opposite, reduction involves the loss of oxygen. A gain of hydrogen. Or a gain in electrons, a gain of electrons. Okay, so there's again three different ways that reduction can occur. Okay, and they're obviously opposite to the ways that oxidation can occur. Okay, and as the name suggests, reduction involves a reduction or decrease in oxidation number. Okay, so that's an easy way to remember it. Reduction reduces the oxidation number. Okay. And so these are kind of important definitions to remember which one's which, okay? They're kind of easy to remember what sort of they both together mean, okay? But it's important to remember that reduction means a reduction in the oxidation number, and oxidation means an increase in oxidation number, okay? So it's these definitions on the side here, okay, outside the curly brackets, that are really important. They're the main ones to remember, okay? And so another way to remember this in terms of the way electrons dictate whether a chemical is oxidized or undergoes oxidation or undergoes reduction. Okay, we use a bit of a silly little acronym here. So we have oil rig. Okay, this might sound silly. Okay, but what this says is that oxidation involves loss of electrons. Okay, so what you have to remember is that oil rig relates to electrons, okay? Electrons. Okay, so oxidation involves loss, that's where the oil comes from, OIL. Okay, and reduction involves gain. So that's a good little acronym that helps you remember, which way the electrons are going when something undergoes oxidation and when something undergoes reduction. Okay, and so the rig means reduction. I'll just write red, reduction involves gain. Okay, so that's what's important to work out. These are kind of the important things to remember. Okay, so you have to remember that oxidation involves an increase in oxidation number. Okay, or if we look at oil rig, it involves the loss of electrons. So the two things you have to remember: loss of electrons and an increased oxidation number. And reduction involves a reduction in the oxidation number, or if we use oil rig, it means a reduction involves the gain of electrons. Okay, so these are also very important to remember. Okay, this area here. Okay, oil rig is very key. And remember that oil rig, you might be able to work out what the oil and the rig stand for, but it's important to remember what's being lost and what's being gained, okay? And we're talking about electrons when we're using oil rig. Okay, so these are some definitions. Okay, it's all a bit wordy, okay, but these are the key points, okay? And what happens is that, if something undergoes oxidation, okay, we can say that it is oxidized. Okay, it's just another way of kind of putting it. We can say, a substance is oxidized or it undergoes oxidation. They are interchangeable. So a substance is oxidized, and similarly, reduction means something is reduced. Okay, so there's a lot of definitions here, but they kind of you can kind of really work through them and think about what they all mean just by using sort of logic. So reduction involves reduction in oxidation number. That's why we call it reduction. Oxidation involves an increase in oxidation number. Okay, and as for the electrons, we can use oil rig. So oxidation involves loss of electrons, and reduction involves gain, again, of electrons. Okay, so it's kind of, so there we have that. These ones are what oil rig relates to, these asterisked points. Okay, so it's very important to remember all these. Okay, and then the last definition that we're going to talk about, okay, is an oxidant and a reductant. Okay, so an oxidant. Now this is where things can get a little bit confusing. Okay, an oxidant is what we call a species or a chemical that causes oxidation, and it itself is reduced. Okay. It is reduced. Okay, so this is what's important to remember. We see the word oxidant, we think, oh, oxidation. Okay, but we have to realize the oxidant does not undergo oxidation. Okay, it does not. The oxidant causes oxidation and is reduced. Okay, and vice versa, the reductant causes reduction and is itself oxidized. Okay, so that's what's important to remember. Okay, the reductant causes oxidation and is itself oxidized. Okay, so these kind of so we know this tells us that every time oxidation occurs in a chemical reaction, reduction must be occurring to something else. Okay, and so we see that that's why we call a redox reaction a redox reaction. Okay, we don't have an oxidation reaction and a reduction reaction. Okay, because they both have to happen within the same reaction. Okay, one cannot happen without the other. Okay, and so we have to remember a reductant is oxidized. Okay, and an oxidant is reduced. Okay, this kind of that's where things can get confusing. So you just need to remember this definition as well. Okay, so there's three key things we need to remember from this lesson. Oxidation involves an increase in oxidation number. Okay, reduction involves a reduction in oxidation number. Okay, again, if we use oil rig, we see that oxidation involves the loss of electrons. Okay, as we've got up here. And reduction involves the gain of electrons. So here's the gain of electrons, okay? And lastly, we need to remember that the oxidant causes oxidation, okay? That's very key. The oxidant in a reaction will cause something else to be oxidized, while it itself will be reduced, okay? And in the same way, the reductant causes reduction in a reaction, okay? So it causes reduction, but it is itself oxidized, okay? And so we're going to do an example in another video. We'll go through a redox reaction and we'll try and identify the oxidant and the reductant.